Good afternoon. Thank you for attending my presentation on barriers to automation and robotics in construction for the Associated Schools of Construction 2020 virtual conference. My name is Daniel Trujillo. I'm a professor at the University of Denver. I'd like to thank my contributing authors, Dr. Eric Holt and Dr. Andrew Mueller from the University of Denver. To begin with, I'd like to give you a little bit around the background and the objectives of our study. The study was to reach a more comprehensive understanding of barriers to and possible solutions as perceived by industry professionals and researchers in the automation and robotics field of study. Currently, we're expanding the study to include contractors, manufacturers, owners, and designers. So our research question is, what are the barriers to automation and robotics adoption in construction? The question is both theoretically and practically important. First, theoretically, there is a significant gap. It is imperative to understand this field because construction itself is a vital economic force. Of the estimated $20.6 trillion in goods and services produced in the U.S. in 2018, construction contributed approximately $840 billion, or 4.2% of GDP. That's according to the AGC's numbers in 2019. Construction employed approximately 7.5 million workers in the U.S. last year, yet in an AGC Autodesk survey of 2019, 80% of contractors reported difficulty in finding qualified workers. Labor shortages threaten broader economic growth and automation and robotics. So why is the research question important? The literature really addresses many aspects related to the adoption of technology and innovation generally in the construction industry, and generally in most industries it is also addressed. But within the construction industry, it is not addressed very closely. Other ways that innovation and adoption of different technologies are addressed is with regards to organizational culture, diffusion of innovation, models of innovation construction are also addressed. Innovation at a project level, research frameworks for construction innovation are quite diffuse, constraints to technologies, geographical differences, and many other issues have been addressed in innovation and construction research, but none specifically with the intent of understanding automation and robotics adoption. So my research model was motivated by themes that we saw in the literature. Clearly in the literature, the productivity, safety, quality, profitability problems within the construction industry can be addressed through automation and robotics. The literature also pointed to problems with labor availability and the possibility for automation and robotics in construction solving this particular problem. There's some wonderful literature around innovation in general. Innovation in construction has created its own body of literature as well. There's also literature on adoption of green building technologies, which is of great interest. Recently, there's a great deal of literature around robotics in healthcare, aerospace, automotive industry, and manufacturing. While this work all identifies thematic fields where automation and robotics are making advancements, it does not broadly address the impediments to these technologies. As we stated in the beginning of our presentation, the research consisted of semi-structured interviews of researchers in construction, automation, and robotics, practitioners at general contractors, people working in construction firms, and consultants working for such consultancies as BIM consultancies within the field. So the method we used, participants were contacted within our personal and professional networks initially, and we did use a bit of snowball sampling and referrals and solicitations to reach out to others within the industry. We asked a series of questions to each of these interviewees, and this is an example of the questions we asked. For example, what do you think are the main problems associated with the use of automation and robotics technology in construction? How do you think barriers can be minimized? Number 4, how do you think barriers can be minimized or overcome, etc. So we developed this interview protocol, and really what the proceedings that we've submitted here are the pilot test reviews of the interview protocol. We conducted the interviews and transcribed the interviews and to code those interviews. So we compiled and coded the interview material both by hand and using in vivo. Initially, we did this by hand to assess emergent themes and code categories. We also experimented with using the in vivo software to do the same process. So we developed level 1 categories of barriers to automation, robotics, and construction. The flowchart here really demonstrates the process that we took, and then we intend to expand it and use the final 3 boxes there to develop a set of binary values for each barrier and use some sort of general linear model to assess the difference between owners, contractors, and researchers and the themes that we're coming up with. But that's for a later time. So the results, we then went to first order concepts, and this is an example from question 1. What do you think are the main problems associated with the use of automation, robotics, technology, and construction? Knowledge base. Technologies are available but unknown to the industry. There was a lot around the sites, uncontrolled or undeveloped sites. There's a complex environment. We heard this from both the construction, automation, robotics researchers who are researching specific technologies, as well as the practitioners, the contractors that we and the contracting representatives that we spoke with. So no software available that can process complex environments. Technologies need to be scalable. There needs to be repetition. We also interviewed researchers in the UK, Finland, and Brazil, and it was interesting to see some different perceptions. For example, the researcher from Brazil talked about the mentality of the industry sector, engineers, and professors, but he also talked about how construction is a very viable job area in Brazil, and there is resistance to the technologies, these robotics technologies that could potentially replace a very steady industry within the country. So the results that we found in this initial pilot study were the first order concepts led to grouping of second order themes, and those were complexity of job sites came up, team makeup, cultural buy-in, which is something that we also saw in literature in general, in innovation literature, and that was sort of one of the things aligned with organizational culture. The maturity of technologies made a big difference according to these interviewees. There were design issues that they ran into, knowledge and know-how became issues, and then the diffusion of the technologies. Interestingly, these same themes sort of appear in the adoption of green technologies in the construction industry. So after all that, we broke it down and we came to really 3 main categories of barriers to automation, robotics, and in construction. So culture, technical aspects, and teams. And really the buy-in from the culture was both on the contractor side and within innovation within these general contracting firms as well. This was identified by researchers. Clearly there were technical aspects that many of them identified. And then the composition of teams was very important in the themes. So through the 7 questions, we really narrowed down the main barriers as being cultural, technical, and dealing with teams. We look forward to expanding this study to see the effects of owners and manufacturers' perceptions as well. Presently, we see the theoretical and practical implications. We think that construction firms, educators, designers, and owners need to adjust their cultures to support innovative technologies such as automation and robotics construction. They need to be open to adopting these new technologies. Finally, I'd just like to thank the ASC for giving us this opportunity to present virtually for the 2020 ASC conference proceedings. My name is Daniel Trujillo. My email is daniel.trujillo@du.edu. I'd be very interested to hear from anyone who is interested in this topic, get feedback, and learn from you. Again, thank you very much for taking the time today to listen to my presentation on our research. Thank you so much.